Yes, I want to use this type of question to illustrate that many times we see this kinds of questions in various topics where we are required to mention what the gradient of a particular graph represents. In this question 1.3, if you look at it, we are given a graph of work done against the time, and we are asked what does the gradient of this graph, what does it represent? And the very first thing we need to know that yes, gradient is changing y-axis divided by the changing x-axis. So if you look at in this very case, you will see okay, w divided by the work done divided by the time, the change in time. You can see that this is a typical example of power. So you can see the power is the rate at which work is being done, and that's what the graph represents. And also we also need to know this question can come in various forms. So I've brought out two examples here in Ohm's law. You can see changing voltage divided by the change in current. In this very case, you will see is an Ohm's law, and this will give us resistance. And we also know sometimes they might interchange this graph, might interchange the positions, just to test our understanding. So if, for example, in the exam you see current here and you see a voltage here, then you know your answer will be the inverse of the resistance. But in this example, our answer is the resistance, because resistance is equals to change in voltage divided by change in current, and that's Ohm's law. Yes, I also think of another example. Under photoelectric effect is also common. Under photoelectric effect, you can see the maximum kinetic energy of photoelectrons, and this one represents the x-axis, represents the frequency. So if you are given this graph, for example, you may also be asked to what does the slope of this graph represent. You will see that this one is a Planck constant, because we know that the energy is equals to the Planck constant multiplied by the frequency. So watch out for this type of question in the exam. They come in various forms. They can use any equations. Just work out what the gradient represents, then you go to your formula sheet,